A good day to Dr. Salma. We are from Network Engineering course. Today we're going to present our operating system lab project, and the topic for our project is reader writer's problem of thread with locks and sephamo. For this group project, we have 5 members in our group. The objective of this lab is to implement a synchronization mechanism for a multi-threaded system where threads can either read from or write to a shared file. The second objective of this project is to develop a robust synchronization mechanism using a mutex lock and semaphore to control to the access file. And for the third objective is to implement a synchronization mechanism for managing the concurrent access by multiple threads to a shared file, ensuring a safe and efficient reading and writing operation. For an introduction, as we all know that the reader-writer's problem has addressed the challenge of managing a concurrent access to a shared file. Because of that, the synchronization mechanism is crucial in order to maintain the data consistency and integrity. Because of that, the objective is to allow multiple readers to access the resources simultaneously while ensuring the writers to have exclusive access when writing.
Okay, so for the next part, which is the problem description for this project, the main problem that needs to be solved when dealing with reader-writer problem is that threads need to access a shared files where there can be multiple readers but only one writer at a time. Next, there are also some conditions in solving the reader-writer problem, which is no concurrent writes, no reads during a write, no writes during a read, and concurrent reads allowed. All these things relate to the importance of the mutex locks and semaphore, which is to ensure the mutual exclusion, allowing only one thread to access the resource at a time, and also to signal and manage the availability of the resources. Okay, so for the next part is about the project requirement. The requirement for this project is divided into 3, which is the programming language used, the operating system, and the control variables. The language used is C, and as for the operating system, we use the Linux or Unix system, and there are 3 control variables exist in the project, such as mutex semaphore, write mutex, and read count.
Okay, so in our program designs, there are algorithm flow. So our program design maintains synchronization between readers and writer via an organized algorithm flow, as you can see in the slide here. So the primary flow charts begins with the application asking the user to read, write, or exit. Depending on the user selection, the application invokes the relevant function, read or write. So in the write function, the program logs the mutex semaphore, determine whether a writer is active, and waits as needed. If no writer is currently active, it sets writer active to true, unlocks the mutex semaphore, and locks the write mutex. The writing process then carry out, and the system status is reviewed before prompting the user for more input. If the user attempts to read while writing is in the progress, they are informed that reading is not permitted until the writer is finished. While in the read function, the program logs the mutex semaphore, determines whether a writer is active, and wait as needed. If no writer is currently active, it increases the read count and locks the write mutex if it's the first reader. The reading procedure is completed, and the system status is examined. After reading, the read count is decremented, and if it reaches 0, the write mutex is released. This flowchart ensures that the reader and the writer do not have simultaneous access to the file, hence protecting data integrity. Okay, for the next slides, there are 5 functions that we were using for completing this task. First is wait. This wait function is to lock a mutex to prevent other threads from entering a critical sections. The second is signal. Signals function is used to unlock a mutex to allow other threads to enter a critical sections, while reads functions is manage the reading operation. It checks for active writers, increment the reads counts, and allow reading if no writer is active. After reading, it decrement the read count. For the next function is write. Manage the writing operation. It waits for no active readers, locks the write mutex, and perform the writing task. It ensures exclusive access to the file during writings. For the last function is check. This function is used for monitor and display the system status, including the number of active readers, and if a writer is writing, it aids in debugging and monitoring the program states. Okay, for the next slide is synchronization logics. How the mutex locks and semaphores are utilized. So in order to synchronize readers and writers, synchronization logic make use of a mutex locks and semaphores. Mutex prevents resituation by enabling only one thread to run a critical region at any given moment. The mutex semaphore and the write mutex manage access to share resources, guaranteeing that only one writer can write at a time, while several readers can read without disturbance. Semaphores help to coordinate access by allowing readers to access the file while no writer is active. This synchronization logic provides data integrity, program stabilities, and the smooth executions of concurrent reads and write activities.
Okay, next is for our function implementation of our code. Okay, first we are going to see the wait function. The purpose of this function is to lock the given mutex m, and when the m lock is called, the mutex is locked. This means that if another thread tries to look the same mutex, it will have to wait until the mutex is unlocked. Okay, next for the signal function. As you can see here, the purpose of this function is to unlock the given mutex. Okay, how it works is when mlock is called, the mutex is unlocked. This will allow other threads that are waiting for the mutex to be able to lock and proceed. The third one is for the check function. The check function output the current status of a system involving readers and writers. It uses some variables such as write active and recount, which is to determine the status and whether reading or writing is allowed. Okay, next, first we start of the function, which is it prints a message indicating that it is checking system status. Okay, the second one is well, it is checking if any writers is active or not. Okay, firstly, if the writer active, and check whether if the writer active variable is true, and it will print any writer writing yes, and for in false is there are if false there are no writer ratings. Okay, for the third one is it display the number of active reader, which is show and which is out as number of readers reading, and followed by a read count, and it prints the number of readers currently reading as stored in the read count variable. Okay, for the fourth one is whether to check is if reading is allowed. Okay, if non-writer is active, check if no writer is active, then is if it true that though there are no writers active, the reading is allowed and yes. And if it's false, it prints reading allowed no. And lastly, checking if writing is allowed. If the writer is not active and the read count is more than equal to 0, it check if no writer is active and read count is more than 0. If both conditions are true, it will print writing allowed. If either condition is false, it prints writing allowed, not allowed. Okay, next we're going through the read function. The read function manages how a reader access a shared resource in a multi-threaded environment. And it also uses mutex to ensure that the resource is accessed safely. Okay, next we looking the mutex, which is by the code wait mutex underscore semaphore, and it's locked the mutex semaphore to gain exclusive access to the following code section. Next, second one, we are waiting for the writer finish the writing. While the writer active, and if a writer is active, the reader waits. And the signal will unlock the mutex to allow other thread to use it. And it will wait for 100 milliseconds before retrying. And it will relocks the mutex to checks again by wait mutex semaphore. After that, it will increment the reader count by 1. Increment the active reader by 1. If read count is equal to 1, it's lock the write mutex to prevent writers from accessing the resource. And then it unlocking the mutex, which is use signal mutex semaphore to allow other threads to proceed. And then proceed to reading section, and it will print out the message indicating that the reader is active. Then lastly, we'll locking the mutex again using wait mutex semaphore to update the reader count safely. Then decrement the reader count by 1. Then unlocking the mutex again by signal mutex semaphore. Lastly, print a message indicating the reader has finished reading. Then increment the reader count and call checks to check the system status. Okay, next we proceed to the writer function. Writer function also same as reader function, but when the writer is writing, the reader and the writer cannot access the file. Not different from readers. When the reader is reading, the writer cannot writing the file. Meanwhile, the reader can read the file. Whenever the reader or writer want to read or write the file, the system will ask, is the writer's finished writing? If no, you can access the file. If yes, it will proceed to run a file again. Then it will proceed for the reader or writer to access the file. Next, we are moving to code listing. Okay, first one, you can look here that all the header we use for this code, and below it, there are some definition that we defined earlier, and our variable that we define at the global variable. Next, we can see that a wait function and below other function. And next, we can see their check function, which is to check the system status. Second one, we can see the function for the readers to read, as I explained before, and you can see clearly the code here. With this is the function for the readers to read. And when the readers read, the other readers can reading also, but the writers cannot write the file. Okay, the third one, as you can see, this one is the function for the writers to write. This function is quite long because there's some scenario where when the writer is writing, the reader and the reader cannot read the file while the writer is writing. Also, same goes to the writer. It also cannot write the file when the writer is writing. And when the readers want to read the file while the writer is writing, it will ask whether is the writer finished writing or not. And if it's no, the writer is still writing. And if it's yes, the system will execute the system will execute the writer to finish the writing. Then the reader will access the file for the next session. Lastly, for the main function of our code, which will execute the whole system, if you can see, it shows that the while is it true, firstly it can do is it will print out that you are currently accessing a file. Then are you a reader? Write type E to exit. Then if it is E, it will break and exit the system. And as if it is R, the thread will read as a reader. And as if it was a writer, sorry, and it will going for a writer to writing the file. Then else it will be invalid input, which are our error handling.
Hello, my name is Len Malangkapo. I'll be presenting the test scenario results. So in we will have 5 test scenario results, and the first one is a writer is writing and a reader is attempt to read. So when a reader is attempting to read while a writer is writing, the program will automatically block the reader from entering the program. They will have to wait until the writer is finishing writing. The writer, when the writer is about to write, the mutex will turn on and that will help block the reader. The second test scenario result is there is no there is no writer writing, but a reader attempts to read. This is allowed by the program. When there is nobody in the system, a reader is allowed to read. The third test scenario result is no writer writing and no reader reading, but a writer attempts to write. This is allowed by the program. So when a writer attempts to write, we will press on W as it represents a writer. So the mutex will turn on, not allowing any reader or writer to enter after the writer has acted. The fourth test scenario result is a writer is writing, but there is no reader reading. But another writer attempts to write. This is also not allowed by the program, whereas when the first writer was attempting to write, the mutex would automatically turn on, not allowing any reader or writer to write, a reader to read or a writer to write. So the next writer will have to wait until the first writer has finished writing. Once the writer has pressed on Y, that indicates it has already finished writing, the other writer will be allowed to write. The fifth scenario is no writers, but there's a reader reading, and a writer attempts to write. So this is also not allowed by the program. If there's a reader reading, the mutex will turn on and block anybody else from entering, either a reader or a writer. So the writer will have to wait until the reader is finished reading. Once the reader is finished reading, he will press on Y and then the writer will have his chance to write. Now is error handling. We have 3 error handlings. So the first one is input errors. So as you can see in the picture below, the program will ask you for an R that represents reader, a W that represents writer, and you can exit by typing E. If you write anything besides those 3, an invalid input will pop up and it will ask you to enter either R, W, or E. That is the input error handling. The second error handling is a reader attempts when a writer is active writing. So as the test scenario before this,
A reader cannot enter the program if there's an active writer writing. So the mutex will turn on for the writer, not allowing any reader or writer to enter the program. So this is one of the error handling that's in the program. The third error handling is the active writer and another writer attempts to write. So this is not allowed by the program. So what the program does is when the first writer is writing, the mutex will turn on, not allowing any reader or writer to enter the program. So the next writer that attempts to write will have to wait until the first writer is done writing. Once the writer has been done writing, the first writer will have to press on Y to indicate that it's done writing. And if it's not done writing, he has to press N that indicates it's not done writing. But when the writer has done writing, you press Y, and then the next writer will have the attempt to write.
So we proceed for our execution of our system. The video shows the execution of our system. So we proceed for our execution of our system. The video shows the execution of our system. So we proceed for our execution of our system. The video shows the execution of our system. So we proceed for our execution of our system. The video shows the execution of our system. So we proceed for our execution of our system. The video shows the execution of our system. So we proceed for our execution of our system. The video shows the execution of our system. So we proceed for our execution of our system. The video shows the execution of our system. So we proceed for our execution of our system. The video shows the execution of our system. So we proceed for our execution of our system. The video shows the execution of our system. So we proceed for our execution of our system. The video shows the execution of our system. So we proceed for our execution of our system. The video shows the execution of our system. So we proceed for our execution of our system. The video shows the execution of our system. So we proceed for our execution of our system. The video shows the execution of our system. So we proceed for our execution of our system. The video shows the execution of our system. So we proceed for our
Okay, so in conclusion, we successfully developed a reader-writer synchronization in C++ using mutexes, allowing for concurrent reading and exclusive writing while retaining data integrity. We use mutex locks and semaphores to ensure that numerous readers could access the file without interfering, while writer had exclusive access when necessary. Our method resulted in reliable performance, backed up by extensive testing and solid synchronization logic, ensuring the program dependability and efficiency. This project not only achieved its goals, but it also provided a vital insight into appropriate synchronization approaches for managing concurrent read and write activities in multi-threaded contexts.
Thank you for listening to our presentation. That's all from us. Thank you.